Although the standard form of a parabola has advantages for certain application, it is not helpful locating the most important point on the parabola at the turning point. So we're going to learn about a form of a parabola where the turning point is fairly obvious. So first, without using a calculator, sketch below on your own set of axes. So let's say that I have my y-axis and my x-axis. What we remember from the last lesson is that since 2 is positive, it's going to be a smiley face one. It's going to be at 0, 0. We also know that the point is going to go through 1, 2, and negative 1, 2, so it should look like this. My next one, y equals negative 3x squared. It's going to still go have the y-intercept as 0, 0. But the next point is going to be 1, negative 3, and negative 1, negative 3. So it's a sad parabola. So if we have a parabola in the form of y equals ax squared, then it has a turning point at 0, 0, because that's our y-intercept and our x-intercept. So now we would like to try to develop a pattern to see how function can have its graph shifted. So consider this basic function, f of x equals x squared, and the more complex quadratic function, g of x equals x minus 2 squared minus 4. The graph of f of x equals x squared is shown on the grid already. Using your calculator to generate a table, sketch a graph of g. So I've created the graph in Desmos, and then I used the little gear function above where you type in the equation to find the table. So my first point of this one is that the table itself is kind of hard to read because it doesn't show the symmetry, so I'm going to actually use the graph itself. There's one point at 0, 0. The next point that goes through the x-axis is at 4, 0. And it looks like the turning point is at 2, negative 4. The next point it goes through is 1, negative 3. Looks like it also goes through right here. And we have our graph. You can also put a point at negative 1, 5. And the same on the other side. So here is our new graph. Using our new graph, how would you need to shift the graph of f of x to get the graph of g of x? So we're talking about how do I get this point to this point? It looks like I need to shift it to the right 2 places and down 4 places. So where can I find those 2 numbers in the graph, the equation? Well, I have a 2 here and I have a 4 here. But I also have a negative 4, sorry. So the negative 4, what up? And the 2 is up in the original equation. So what is the turning point? Well, the turning point of this one is at 2, negative 4, which we see up here, 2 and negative 4. So let's keep looking at this pattern, but more simply. So we have the quadratic equations. The one that's in there already is y equals x squared. So we're going to need to graph the other 2. So my blue graph is going to be this one, y equals x squared plus 2. The y-intercept is going to be at 0, 2. You'll notice in the original equation, or the original graph, it goes up 1 over 1. Same on the other side, and then from there up 3 over 1. So here is the graph of y equals x squared plus 2. And the next one is going to be in red, and we have the same pattern of up 1 over 1, up 3 over 1. So what was the effect of adding a constant to the overall function? Well, adding moves it up, subtracting moves it down. So the coordinates of the parabola, so of the blue one, the coordinate of that turning point is 0, 2, and the coordinate of the red one is 0, negative 4, which you'll notice we have a 2 and a negative 4. So the coordinates of the turning point of y equals x squared minus 150 would be 0, negative 150. So now let's see about that number added and subtracted from the input value, x before it's even squared. So y equals x plus 3 squared and y equals x minus 1 squared. Using your calculator, generate tables, sketch these two quadratics, and label. So y equals x plus 3 squared is right here. And so the turning point is going to be negative 3, 0. And then the actual pattern is the same, where it's up 1 over 1, up 3 over 1. For the next one, the turning point is 1, 0, and the pattern is the same, up 1 over 1, up 3 over 1. So why is the horizontal shift counterintuitive? So adding to the x shifts it to the left, and subtracting to the x shifts it to the right. State the coordinates of the turning points of each of the parabola you drew. So for y equals x plus 3 squared, the turning point is negative 3, 0. And for the other one, it is 1, 0. Determine the coordinate of the turning points of each of the following quadratics. Note that the value of a is irrelevant. So using the information that we know up above, we're going to look at just this section first. And that has to do with the x value. So when it's minus, it's going to actually be a plus. So 8, negative 1, and 3. And what we know about on the previous section, this part tells you if it's a positive or negative y. So positive 5, negative 4, negative 10.